Data compression enables you to store more data in the same amount of space. This, on its own, is a huge benefit, but there's more. Not only does this help you lower the effective price of your file system, but it also reduces the overall size of your backups, so you spend less on backups too. Your file systems will also be faster, enabling you to achieve higher levels of throughput because, with data compression, FSx for Lustre reads and writes more data in the same amount of time. This Getting Started video is the first in a series of videos I'm putting together on the data compression feature of Amazon FSx for Lustre. In this series, I will also be covering monitoring, reading and writing with data compression, using data compression with data repositories, and some of the cost benefits and design considerations for using data compression. In this Getting Started video, I'll do a quick overview of Amazon FSx and Amazon FSx for Lustre. Then I'll dive deep on the data compression feature, how it affects read and write operations, and how to calculate data compression ratios and space savings. I'll also talk about how to estimate how much disk throughput may increase as a result of using data compression. Amazon FSx is an AWS service that provides fully managed, open source, and commercially licensed file systems. One of those file systems is the world's most popular high-performance file system, Lustre. Amazon FSx for Lustre makes it easy to launch and run high-performance Lustre file systems. These file systems can scale to hundreds of gigabytes per second of throughput and millions of IOPS, while delivering consistent sub-millisecond latencies. It offers a range of storage options and features to optimize price and performance. Data is automatically encrypted and is compliant with global security standards. It's POSIX compliant, so you can use it with your existing Linux-based applications without having to make any changes. These file systems can be optionally linked to an Amazon S3 bucket, so S3 objects are transparently presented as files in the Lustre file system. We use LZ4, which is the Lustre community-trusted and performance-oriented lossless compression algorithm. With the optional data compression feature enabled, you can lower your cost by provisioning smaller-sized file systems and spend less on backups because the backup data is also compressed. And because data is automatically compressed as it writes to disk and uncompressed as it reads from disk, FSx for Lustre can read and write more data in the same amount of time, giving you an increase in throughput. That means it's transactional, again compressing data as it writes to disk and uncompressing data as it reads from disk. There is no need to change user behavior or applications because data compression is automatic and transparent. Data compression can be enabled for new or existing file systems, but remember, it's also transactional, so existing data will not be automatically compressed when you enable data compression. Our user guide has some easy steps you can follow to compress data of existing file systems. When a file system is created, Amazon FSx provisions one or more Lustre file servers depending on the storage type, the deployment type, and the storage capacity of the file system. Each Lustre file server has network, cache storage, and disk storage components, each with their own performance characteristics. These are the basic components of an FSx for Lustre file system without data compression, or having a data compression type of none. A file system with data compression enabled or having a data compression type of LZ4 looks very similar, but there is one important difference. These file systems have servers with compression engines. FSx for Lustre automatically compresses data as it writes to disk and automatically uncompresses data as it reads from disk. Let's see what typical write operations look like. Lustre clients issue a write operation to one or more Lustre file servers. The data enters the network interface, is written to cache storage, then compressed as it's written to disk. Some read operations could come strictly from cache. In this case, the Lustre clients issue a read operation to one or more Lustre file servers. Data is read from cache and delivered back to the clients. When FSx can deliver content strictly from cache, data compression isn't involved. But other read operations could come from disk. Again, Lustre clients issue a read operation to one or more Lustre file servers. The requested data isn't available in cache storage, so it needs to go to disk. The read is automatically uncompressed, written to cache storage, then delivered to the client. Before I go into the details on how to estimate how much performance increase you could see when using data compression, I need to define a few terms. The data compression ratio is the ratio between the uncompressed size and the compressed size, and it's typically notated as an explicit ratio like n/1. To calculate data compression ratios, you divide the uncompressed size by the compressed size. This could be for individual files, directories, or even the entire file system. For example, if I have a file with an uncompressed size of 35 gigabytes, and it compresses down to 10 gigabytes, then the data compression ratio for this file is 3.5 or 3.5 to 1. Another term that's important to understand when dealing with data compression is space savings. Space savings is the reduction in size relative to the uncompressed size, typically shared as a percentage. To calculate space savings, take the compressed size and divide it by the uncompressed size and subtract that from 1. Here's an example. If I have the same file with a compressed size of 10 gigabytes and an uncompressed size of 35 gigabytes, I divide 10 by 35 and subtract that from 1. This gives me 0.714, or a space savings of 71.4%. That tells me that this 35 gigabyte file is using 71.4% less space because of data compression. This frees up a lot of space for additional data. The file system components I showed earlier have different performance characteristics. These characteristics are available in a table found in the Amazon FSx for Lustre user guide in the performance section. This table I'm showing you now is a subset of the table available from the user guide. Each deployment type has different performance or size characteristics as it relates to network, cache storage, and disk storage. And these characteristics are proportional to the storage capacity of the file system. What we don't have here is the performance characteristics as it relates to data compression. The amount of data compression is highly dependent on the type of data, which varies greatly from customer to customer and file type to file type. But if we had data compression ratios of the data we're reading and writing, we could calculate new estimated disk throughputs as it relates to data compression. For example, if we have a Scratch-2 file system with a data compression ratio of 3.5 to 1, when we multiply the data compression ratio of 3.5 by the disk throughputs of that file system, it gives us new estimated disk throughputs. If we have a persistent 50 file system storing data with the same data compression ratio, then our new baseline and burst estimated disk throughputs are 175 and 840 megabytes per second per terabyte. For a persistent 100 file system, it is 350 and 840 megabytes per second per terabyte. And for a persistent 200 file system, it is 700 and 840 megabytes per second per terabyte. To find the new estimated aggregate performance of the file system as it relates to data compression, multiply the data compression ratio by the disk throughput. Again, if I have data with a data compression ratio of 3.5 to 1 in a persistent 200 megabytes per second per terabyte file system, then my new estimated baseline disk throughput is 700 megabytes per second per terabyte. There are a number of benefits related to data compression. You store more data in the same amount of space. You spend less on backups because the data you're backing up is compressed. And you drive more disk throughput to your file system because we can read and write more data in the same amount of time. If we use the same data compression ratio example of 3.5 to 1, we'll store 3.5 times more data, we'll spend 3.5 times less on backups, and we'll drive 3.5 times more throughput because of data compression. Today we saw how data compression works and how it can be used to help you save cost and increase performance for your FSx for Lustre file systems. Thanks for watching this Getting Started video on data compression with Amazon FSx for Lustre. And to learn more about AWS, go to aws.amazon.com.